Okay, today we're going to talk about multiplying and dividing monomial expressions with the same base using properties of exponents. So we're really going to focus on the developing properties of exponents. And our learning objective is how do we multiply powers that have the same base. Okay, and our vocabulary is product of powers and power of powers. And we'll go over each one of those. Okay, first up is product of powers. The words are a little lost in the top of the page there, but product of powers is, so if we look below, here's an example of the product of powers here. Okay, I just made it a little bigger so you might be able to see it better. Now, we refer to this thing as a power, so anything with a base and an exponent is a power. Okay, so 4 squared is a power, as well as if you can actually square 4 to get 16, 16 is a power. We would say 16 is a power of 4. It's also, by the way, a power of 2. But this, the object before it squared is also referred to as a power. So that's called a power, and this is also called a power. It's much the same way as a sum can be written as 3 plus 4. That's the sum of 3 and 4. And 7 can also be considered a sum of 3 and 4. So we call the result of an addition problem and the addition problem itself, those are both called sums. Okay, so the product of powers says that you can, let's look at this here. It says when we are taking 2 powers, so here I'm taking 4 squared and 4 to the 5th power, and I'm multiplying those two things. Okay, so it's the product or the multiplication of 2 powers, 2 or more powers. Well, if you think about it, 4 squared is just 4 times 4, right? That's 4 squared. And 4 to the 5th is 4 times 4 times 4 times 4 times 4, which is 4 to the 5th. Well, when we write it out with repeated multiplication, like in the second step, we can see there's 1, 2, 3, 4, 5, 6, 7 4s. So that's the same as 4 to the 7th. Okay, similarly, if I had a base that wasn't an actual number, if I have a base below here, I have a base of a. So if I have the base that is a variable, let's say I have a to the 1st power times a to the 6th power. Well, a to the 1st power is just a, right? And a to the 6th power is a repeatedly multiplied by itself, or a represented as a factor 6 times. So here's a factor, 2, 3, 4, 5, 6. So this exponent refers to how many times that base is represented as a factor in the repeated multiplication. So here's a times a times a times a times a times a, and here's another a. So altogether, if I were to write that with exponent notation, that would be a to the 7th. Okay. So the rule is that when you're multiplying powers with the same base, keep the base and add the exponent. So this is, let's just go over this. When you are multiplying powers with the same base, so here x is the same base, x is the same base, we keep the base, so I keep the base of x. I do not add the base together to itself. I keep the base of x and I add the exponents. So up here, you could see that we did 1 plus 6, and that was 7. Okay. And the first example was 4 squared times 4 to the 5th power, and that was 4 to the 7th power. So we kept the base of 4, and we added the 2 and the 5 to get the 7. This is called the product of powers. Okay, and this is the second page of the lesson, and I accidentally made a mistake and wrote product of powers at the top of this page. It really should be called power of a power, and down here too, power of a power. This is the next rule that we're going over. So the power of a power rule says that if you have a power, 5 to the 3rd is a power, and that power is being raised to another exponent, it is called a power of powers. So let's look at what this means. The base of the 2 here is 5 to the 3rd. So this 2 is saying represent 5 to the 3rd as a factor twice. Right, so let's write it with multiplication. 5 to the 3rd, that's represented as a factor once. 5 to the 3rd, that's represented as a factor twice. Okay, well here we get to the product of power rule we saw on the last slide. that says, well, both those 5's are the same, so they have the same base, so we keep the base and we add the exponent. Okay, so it turns out, let's look at what we started with. We started with 5 to the third, all raised to the second power, and we ended up with 5 to the sixth power. Okay, similarly, if you have a base that's a variable, this one, the base of this 2, the exponent of 2, is the x to the third. So this 2 is saying represent x to the third as a factor. Remember, a factor is a part of a multiplication problem. It says represent it as a factor twice. Okay, we did that. And now we are in the situation in the last slide. So let me just go back to the last slide here. The last slide said product of power. So I want to have 2 bases and 2 exponents, or when there are 2 powers represented here, then you keep the base and you add the exponent. Okay, so the power of a power rule, you can see if you look at where we began and where we ended here. So x to the third all raised to the second power gets you x to the sixth power. So you can see this rule is x to the n raised to the p power is x to the n times p. Or you can write that without the multiplication symbol in between. All right, so make sure you have this in your notes. So we're going to try a few examples here. So if you want to pause the video, you can try these on your own, or you can watch me do them, and then there's some more you can try on the next page. The use of the parentheses here means that the 3 has a base of x times y, right? If it were just x, y to the third, that 3 would only have the y as a base. But since we're using parentheses here, that means that the base is x times y, or the product of x and y. So let's write that out. So that means that xy has to be represented with repeated, or it's represented as a factor 3 times. Okay, well, we don't really need parentheses here, so we can just write it as x, y, x, y, x, y. Well, with multiplication, that's all. Multiplication is commutative, so I can just write those x's next to each other and the y's next to each other. Well, x times x times x is x to the third. Y times y times y is y to the third. Okay, so in the end, the quantity of x times y to the third is x to the third, y to the third. All right, and if you look back at what we had, there's a shortcut here. Okay, oh, actually, that's what let me just put that back in because the rule is right below. The rule is if you have a product inside of, if the base of your exponent or the base of your power is itself a product, like in this case the product of a and b is the base to the power that's raised to the n, then what you can do is just sort of distribute this n into both of these factors. So this is the same as a raised to the n power and b raised to the n power. Okay? So the next thing that we're going to experiment with is what happens if you have a fraction raised to a power. All right? And this is fairly simple, so we can think of this again, just going back to our understanding of exponents. That 3 says represent 3/4 as a factor 3 times. Well, that's fairly simple because if we multiply all those fractions together, you'd have 3 times 3 is 9, times 3 is 27, over this is 64. Okay, so the rule below is if you have a fraction raised to an exponent, all you really have to do, by the way, let me just look up here, 27 is 3 to the third and 64 is 4 to the third. So the shortcut is if you have a fraction raised to the nth power, you would just raise a to the n over b to the n. So you'd raise the numerator to that exponent and the denominator raised to that exponent. Okay, so here's some ones that you want to try. So pause the video and see if you can work these out based on what you've already discussed. Okay. Okay, and so we'll come back. So hopefully you've tried some of these because it's important to get a little practice in. And we'll discuss these. So remember, when you have a base of just x and you don't see the exponent's always 1. So here we use the product of powers rule. That's because none of these powers are being raised to another power. They're all just powers that are being multiplied together. Okay, or there's 3 separate bases. You don't have one power with one base being raised to another exponent like you see in number 2. Okay, well that's just x to the 4 plus 3 plus 1, which is x to the 8th. Okay, all right, let's try number 2. Number 2, if you recall, this is when you have a fraction raised to an exponent, and we can just distribute that exponent into both the numerator and denominator. So in the numerator I have a squared raised to the 4th power, so that's going to be our power of power rule. And then in the denominator we have b to the 4th. So the denominator is fine here. Let's clean up the numerator here. So the numerator is a squared to the 4th, and that's our power of a power rule. Okay, and so that's a. We keep the base of a, and we multiply the 2 exponents together. So we have a to the 8th over b to the 4th, and there's nothing you can cancel here. That's just as far as we can go. Okay, and the next one, there's no exponents except what, well, there's no exponents written except what you see on the y. So let's just multiply these out, and we can drop the parentheses because there's nothing being distributed into either of these terms. Okay, but you can think of these as being next to each other because multiplication is commutative. So that's x squared and then y to the 3rd power, right? Because this is y squared and y to the 1st power is y to the 3rd power. Okay, for the next one we have 27 squared times 3 to the 5th. So this is a little tricky. In fact, you can, I mean, it's not that tricky, but if I want to, I can write 27 as having a base of 3. So if I want to really simplify it, remember that 27 is 3 to the 3rd. So instead of writing 27 here, I'm going to write 3 to the 3rd all squared, right? Because 27 is being replaced by 3 to the 3rd. And then we have 3 to the 5th. Okay, to simplify this first one, that's the power of a power rule. So it's 3 to the 6th because I multiply the exponents. And then I'm multiplying that by 3 to the 5th. And here's our product of powers. We have 2 powers being multiplied. So I keep the base the same and I add the exponents. And that is the simplification of number 4. Okay, and the last one's fairly easy compared to the other ones, I suppose. So these have the same base of t. Now, even though we can't add the 5 and the c together because they're unlike terms, we can still say that this is t raised to the 5 plus c power. And that's as far as we go because we can't add the 5 and the c together. All right, and that's the last page of this lesson.